Yes, ma'am.
Okay, for your request, today I'm going to start about the organic plants. Okay. You may interest in the organic plants. She's coming the class or not? One
Yes,
of
ma'am.
the person said that, Madam, we want organic chemistry class. Okay, today we are discussing about the nitro compounds. So in this, which are called as nitro compounds, and what is the formula of nitro compounds, how to prepare the nitro compounds, and what are the chemical properties, physical properties of nitro compounds. So this is discussed in this class. Look at this in the picture, N double bond OO. So this is the formula of nitro compounds. Okay. So here, this is the Ambedkar notes, and I have the another notes. I will send that one also. These notes are clear to all?
Yes, ma'am.
It's clear.
Okay. So
Yes,
here,
ma'am.
so it is easy to explain. So that's why I explained by this one. So nitro compounds, the NO2 functional group containing components. So here, this is the formula RNO2. NO2 is called as nitro compounds. R is nothing but the alkyl group. Okay. So in this is the formula of nitro alkenes. Okay. And what is the common name and what is the IUPAC name of this nitrogen compounds? So here the common name is alkyl nitrate. Alkyl nitrate is the common name, and nitroalkane is the IUPAC name. Okay. RNO2 is the formula of nitro compounds. The common name is alkyl nitrate and the IUPAC name is nitroalkane. Already it is written in this chart paper. So here look at this. The general formula of nitro compound is NO2. So here this is the formula RNO2. Okay. So this is the formula of nitro compounds. So in this common name is alkyl nitrate and nitroalkane is the IUPAC name. So these are also classified into three types: primary nitro compound, secondary nitro compounds, and tertiary nitro compounds. So which are called as primary nitro compounds? Look at this. Here, this NO2 group is called as functional group. So this functional group attached carbon is directly, look at this second one. So this is the functional group NO2. So this NO2 attached carbon is directly bonded with the only one carbon atom. So this type of compounds are called as primary compounds. Once I repeat, the functional group attached carbon is directly bonded with the only single carbon, that is called as primary carbon. So here methyl nitrate, ethyl nitrite are it is called as nitromethane, nitroethane. So this is the impact.
Ma'am.
Ma?
Definition once again you repeat, ma'am.
వినబడట్లేదు నాకు. Tell me.
Primary definition ఇంకొకసారి చెప్పండి, ma'am.
Primary carbon. The functional group attached carbon is directly bonded to one carbon atom are called as primary carbon. So how many number of carbons are present? Suppose look at this. CH3, CH2, wait a minute. CH3, CH2, 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 NO2. So this is the functional group. This functional group attacked carbon is this one. Okay. It is directly bonded with only this carbon. It is bonded with this one. This is bonded with this one. But the functional group attached carbon is direct. So that is called as primary carbon. Okay. So in all these structures, that is, if it may be the nitromethane, nitroethane, or it is nitrobutane. So in all these groups, the NO2 is called as functional group, nitro group. It is attacked directly to the only single carbon. So that's why those are called as primary compounds. Then let us take example of secondary. So here, this look at this. So the NO2 group. This is the group. Okay. It is side one and secondary. Hello? May I hear?
Yes, ma'am.
Okay. So here in this structure, this NO2 group attached carbon is CH. This CH is attacked with directly two carbon. From is left side, from one is bottom side. So this type of components are called as, the carbon is called as secondary carbon. Okay. So here this carbon is called as secondary carbon because this carbon is bonded with this carbon and this one. So that's why it is called as secondary carbon. Here its name is 2,2-nitropropane. So total number of carbons are 3 and the nitro group is attached to second carbon. Look at this. So this is the first carbon, this is the second carbon, this is the third carbon. So in this NO2 group is attached to the first second carbon. So that's why it named as 2-nitro. That means the second position, the second carbon is attacked with the nitro group. So that's why these are called as 2-nitro and total number of carbons are 3. Okay. So that's why it is named as 2-nitropropane. Look at this in the bottom structure also. In this bottom structure, first give the numbering. So here 1, 2, 3, 4, 5. From this side also 1, 2, 3, 4, 5. So from the left side or from the right side, the third priorities go for the nitro group. Okay, the third carbon is attacked with the NO2 group. And the total number of carbons are 5. So that's why its name is 3-nitro. Why it is called as 3-nitro? The third carbon is attacked with the nitro group. So that's why it is mentioned as 3-nitro. Then the total number of carbons are 5. So that's why it is maintained as 3-nitropentane. And in all the carbon atoms are having the sigma bond only. So that's why these are the alkane structures. Next, look at for the tertiary alkanes. So which are called as tertiary nitro compounds. Look at this in this structure. So here, this one is the functional group. Functional group attacked carbon is this one, the middle one. It is attacked with 1, 2, 3 carbons directly. So the functional group attacked carbon is bonded with the 3 carbon atoms. So that's why it is named as the tertiary. Okay. So how we can give the nomenclature? So before going to know the nomenclature, first we give the number. Wait a minute. So, sorry for the inconvenience. In this structure, look at this. First, we give the numbering. So, here from this side, 1, 2, 3. Okay. So, from the top also 1, 2, 3. Okay. From this side, 1, 2, 3. So, whatever the position it may be, the second priority is go for the functional group. Okay. So due to that reason, so here in this structure, 1, 2, 3. So the second carbon is attacked with the 1 nitro group and 1 methyl group. So the first priority is go for the methyl group, then after the functional group. So that's why the second carbon is attacked with the methyl. CH3 is called as methyl. So 2-methyl, 2-nitro. The total number of carbons are 3. So that's why propane. Okay. 2-methyl, 2-nitro, propane. Okay. This is the nomenclature for the tertiary nitro compounds. The next preparation of nitro compounds. In the preparation of nitro compound, it is also in your syllabus. It is somewhat difficult in your book. Okay, look at this. Preparation of nitro compounds from alkanes. Okay, alkane formula is RH. So this alkane is reacted with the HNO3, nitric acid. It produces the alkyl nitro compounds. Okay. RH, it is called as RH. It is called as alkane. Alkanes are reacted with the HNO3, nitric acid, in the presence of the 400 degrees centigrade. Then this hydro group is eliminated and NO2 group is added. then it reduces the water molecule. So this is the one of the preparation of a nitroalkane. Okay. Then here one example also present. If instead of the R, we can substitute the methyl group, that is CH3H. It is called as methane. It is reacted with the HNO3 in the presence of 400 degrees centigrade. So this hydrogen and in this HNO3, it is converted to NO2 and OH. Okay. So here this methyl group is reacted with the NO2 group. Then it is called as nitromethane or methyl nitrate. And this is eliminated as, the remaining part is eliminated as water molecule. So this is the preparation method of nitromethane, or it is called as methyl nitrate. Then in this example, another preparation method is present. Ethyl group is reacted with HNO2, HNO3 in the presence of the 400 degrees centigrade. It is also produced the nitroalkanes. Okay. Then comes to your syllabus topic. So this is the second preparation method. Look at this, alkyl bromide. Okay, this is the second preparation. First preparation method is that preparation of nitroalkane from alkanes. Second one is preparation of nitroalkane from alkyl halide. RBR, alkyl bromide. It is reacted with potassium nitrate. Then nitro group is attached to alkyl group and potassium is reacted with the bromide. Look at this reaction. In this reaction, first we can take the alkyl bromide. Okay. So here it is the alkyl bromide. So in this alkyl bromide, the bromo group is more electronegative atom than the alkyl group. So that's why the sigma bonded electrons are shifted toward the bromide group. Then alkyl get the positive charge and bromo group get the negative charge. So this is the step 1. In step 2, we can take the potassium nitrate, KNO2. In this, here these electrons are shifted to the nitro group, then it is converted to NO2 minus and K plus. Then in third step, this R plus is reacted with the NO2 minus, R plus NO2 minus. So this NO2 minus, it is having the pair of electrons. Those electrons are donated toward the alkyl carbocation. Then it is converted to nitroalkane or NO2. Okay. So this is one preparation method. This is the second preparation method. Okay. First, then moves to the third preparation method. Look at this. In this third preparation method, we can take the tertiary alkyl amine. So it is called as tertiary alkyl amine. tertiary alkylamine under oxidation in the presence of the MnO4, it is converted to nitro compound. So here you have the three preparation method. The first preparation method is about the reaction with the HNO3, or it is called as from alkanes. Alkanes are reacted with the nitric acid under 400 degrees centigrade temperature. It forms nitroalkane. Then second preparation method is from alkyl halide. Alkyl bromides are reacted with potassium nitride. Then they produce the nitroalkanes. The third preparation method is that the trialkyl amine, it is reacted with, or it is under oxidation in the presence of the CmNO4, it is converted to nitro compound. Okay, so these are the three preparation methods of nitroalkanes. Okay, then physical properties. So here, because of the formal charges associated with nitro group, nitroalkanes are highly polar compounds. They have high boiling points. The nitromethane is about 10% soluble in water and a high member are insoluble. The nitro group is a resonance hybrid. Two equivalent structures are produced. The two nitrogen-oxygen bonds distance in a nitro compound is identical and equal to 21 angstrom. Look at this in this nitroalkane structure. So here one nitrogen is bonded with the oxygen for the double bond. Another oxygen is having the sigma bond. So due to the reason, so here this nitro oxygen, the N single bond O. So in this, so here in this what happens? So this oxygen atom pair of electrons donated in between the nitrogen and oxygen. Then here double bond takes place and these pi bonded electrons are shifted toward the oxygen atom. Then oxygen get the negative charge and this nitrogen and oxygen get the double bond. So due to this reason, so it is involved in the resonance. After some time what happens? Here, so these negative charged electrons are shifted over here and these electrons are shifted over here. Then this type of structure is produced. Okay, so due to that reason, it is involved in the resonating structure. So here, due to the resonating structures, it is having the high boiling point values. Okay, and this nitromethane is 10% soluble in water and highly compounds are insoluble in the water. Okay. And the bond angles in between the two nitrogen atoms, two oxygens and nitrogen is 21 angstroms. Okay. Then next is about the chemical reaction. Next topic is about the chemical reaction. In this chemical reaction, we are discussing about what is ketoenol tautomeric. So this in the chemical reaction, it is involved in the tautomerism and salt formated structure is produced. So while the transformated structure is produced, what is the nitro form and what is the SU form? Okay, look at this in this structure. So here this is regarding for the nitro compounds. Okay, this is regarding for the nitro compounds. So here in this, what happens? So here one hydrogen atom, it donates the electrons in between the carbon and nitrogen. Then nitrogen, oxygen, 5 bonded electrons are shifted to the oxygen atom. Then oxygen get the negative charge. And this eliminated proton is added to the O minus. Then this type of structure is produced. This structure is called as SE form. Okay, why? Once I can explain it clearly. Look at this. R, C, H, H, N, double bond, O, O minus. So this is the structure of nitro form. So in this, it is involved in the keto-enol tautomerism. So what is keto-enol tautomerism? So here in a particular compound, one of the hydrogen is eliminated as proton. So that proton is added to the high electronegative atom. And this H plus is added here. Then here what happens? R, C, H, double bond, N, O, H. This is O minus. Okay. So these nitrogen, oxygen, double bonded electrons are shifted to the oxygen atom. Then oxygen get the negative charge. What is keto-enol tautomerism? In a compound, the eliminated proton, it is added to the high electronegative atom. When compared the electronegativity of carbon and oxygen, oxygen atom is the more electronegative than the carbon. Okay. So this eliminated proton is attacked with the O minus, then it is converted to OH. So it is called as keto-enol tautomerism. Keto is nothing but the carbon. Okay, enol is nothing but all alcoholic group is produced. So that's why it is called as enol form. Here it is called as SE form. Okay. So bottom is also there. This is for the secondary carbon. So here, look at this. This is for the primary carbon. This is for the secondary carbon. Then next is about here the nitro compounds SE form. It is reacted with the sodium hydroxide. Okay, the H plus in sodium, in the presence of the sodium hydroxide, the OH group hydrogen is eliminated as proton. Look at the first structure. The first structure should be like this. R, C, H, double bond, N, O minus, OH. Okay. When it is reacted with the so this is the structure. When it is reacted with the sodium hydroxide, in the presence of the sodium hydroxide, so this hydrogen is eliminated as proton and the sodium metal is attached here. Okay, so this is the reaction of sodium metal. Understood? So here, the first one is the primary one. The second is secondary alcohol. Third one is the tertiary secondary alcohol. Okay, secondary nitro compounds. Those are also reacted with the Ac form and produce the sodium salt components. Okay, so this is regarding for the reaction with the NaOH, sodium hydroxide. The next is reaction with the bromine, that is called as bromination reaction. Wait a minute. Next is about bromination reaction in the presence of the sodium hydroxide. So here in this, the primary, secondary nitroalkanes are reacted involved in the bromination reaction. They produce the bromo-substituted nitrobenzene compounds. Okay, so here look at this reaction. In this reaction, the sodium hydroxide, it is reacted with bromine, then it is converted to NaOER. That means the sodium bromo oxide substituent is produced and it is eliminate the hydrogen bromide. Then we can take the primary nitroalkanes. So in this primary nitroalkanes, one hydrogen is eliminated as proton and the carbon get the negative charge. It is reacted with bromoxide ion. Okay, bromine is added with the oxygen, then it is called as bromoxide. Then this bromoxide, it is reacted with the negative charge carbon ion. So then it produces this type of structure. Okay. The next reaction, the reaction with nitrous acid. Okay. So look at this example. Look at this. Here we can take the primary nitroalkanes. Primary nitroalkanes are reacted with the nitrous acid. They can produce the alpha nitroso nitroalkane. The secondary nitroalkanes also reacted with the nitrous acid. They produce the alpha nitroso alkanes. This mechanism. In this mechanism, first we can take the primary nitroalkane. Okay, in this primary nitroalkane, so here one of the hydrogen, the carbon is having the 2 hydrogen atoms. So in these 2 hydrogen, one hydrogen donate the electrons to carbon and the hydrogen is eliminated as proton, carbon get the negative charge. Okay, then this type of structure is produced. Then it is reacted with HNO2, nitrous acid. The nitrous acid is converted to OH minus and NO plus. Okay, so that NO plus is added to the negative charged carbon ion. Then it produces this type of structure. So this is called as alpha nitroso nitroalkane. Okay. Then this alpha nitroso nitroalkane, it is involved in the resonating structure. So this type of structure is produced. When it is reacted with sodium hydroxide, then a red color component is produced. So that's why it is the identification test for primary nitroalkene. Okay, then let us take secondary nitroalkene. Nothing but the nitro functional group attack carbon is directly bonded with the two alkyl group. Look at this. In this first one, only one alkyl group, two hydrogen atoms are there. But in this second structure, two alkyl groups and one hydrogen is there. It is called as alpha hydrogen. So it is reacted with HNO2. The NO plus is added instead of the hydrogen because that hydrogen is eliminated as proton. Then it is reacted. Okay. So once I repeat, the primary nitroalkenes are reacted with nitrous acid. They can produce the alpha nitroalkene. When it is reacted with sodium hydroxide, a blue colored component, a red colored component is produced. If secondary nitroalkene react with nitrous acid, then they also produce So, hello. May I audible clearly to?
Yes, ma'am.
Yes, ma'am.
Okay. Yours net also, your connection is also sometimes it is cut. Actually, that's what happened. It disconnected and it is rejoined. You make any problem like this?
Man, it's good from our side now. I think the problem is from your side.
So here, understood in this what so this is class identification test for the nitro compounds also because the primary nitro compounds, primary nitroalkane. So here, when the primary nitroalkane is reacted with the nitrous acid, use the alpha nitroalkane. When it is reacted with sodium hydroxide, then it can produce the red color compounds. So it is the identification test for primary nitroalkane. In the sense of secondary nitroalkane, it is reacted with nitrous acid and produced alpha nitroalkane. When it is reacted with sodium hydroxide, a blue color compound is produced. So in this, the tertiary nitroalkanes does not involve in the reaction with the nitrous acid. Anybody can say what is the reason? Why the tertiary nitroalkanes are not reacted with the nitrous acid? Anybody? Hello? Anybody is there?
Yes, ma'am.
Why the tertiary nitroalkanes are not reacted with the nitrous acid? So I wrote the structure that is tertiary nitroalkane. Based upon the structure, you can explain it easily. So here in the tertiary nitro compounds, all the alkyl groups are present. Here the no hydrogen is there and it not eliminated as the H plus ion and the carbon does not get the negative charge. Okay, due to that reason, it is not reacted with the HN2. Understood? Then the next preparation method is in your book they give some of the knowledge, that is, look at this. So in this, here the primary nitroalkane, it is converted to nitrolic acid and this nitrolic acid is reacted with the sodium hydroxide and it can produce red color solution. So this secondary nitroalkane also reacted with the HNO2 and produce the product. But the tertiary nitroalkane does not react with the HNO2 and it could not produce a product. Okay. Then the next preparation, chemical reaction is that reduction of nitroalkanes. So here we can take the primary, secondary, tertiary nitroalkanes. Those are involved in the reduction in the presence of the lithium aluminum hydride or zinc HCl or tin HCl. Then they produce the alkyl amine. Look at this structure RNO2. It is called as alkyl nitrate. This alkyl nitrate is reacted with hydrogen in the presence of the lithium aluminum hydride. Then it produces the amine product. If we can take the third one, that is tertiary nitroalkane, or it is called as tertiary butyl nitrogen. Okay, tertiary butyl group. So here it is also involved in the reduction. It produces the amino product. Okay. So the main is that when the nitroalkanes are involved in the reduction, they produce the primary amines. Okay. Secondary amines are tertiary amines. Then hydrolysis reaction. So what is the hydrolysis reaction? So here we can take the alkyl amine RCH2NO2. It is reacted with HCl. In the presence of the water, it is converted to carboxylic acid. Okay. So here the nitroalkanes are involved in the acidic hydrolysis. Then they produce the carboxylic acid. So look at this example. In this, we can take the nitroethane. So this nitroethane is involved in the hydrolysis in the presence of the acid. It produces the acetic acid. Okay, so this is the reaction. The next chemical property is that is called as Neff's reaction. Look at this. Next reaction, it is called as hydrolysis of nitroalkanes. So this is visible to all properly.
Yes, ma'am.
So what is next reaction? In this next reaction, primary, secondary nitroalkanes form the sodium salt with Sc form. It is hydrolyzed with sulfuric acid to form carbonyl compound. The primary nitroalkanes produce the aldehyde. Secondary nitroalkanes produce the ketones. Okay, look at this reaction. So here in this first reaction, we can take the primary nitroalkane. In this primary nitroalkane, the R group is substituted with CH2. So in this CH2, one of the hydrogen donate the electrons in between the carbon and nitrogen. So here it donate the electrons here. Okay, this hydrogen donate the electrons in between the carbon and nitrogen. Then automatically these nitrogen oxygen electrons are shifted and nitrogen get the negative charge. So this negative charged nitro O minus, it is reacted with proton. Then this second structure is produced. Okay. So in this second structure, it is involved in the hydrolysis in the presence of the acid. Then the carbon nitrogen bond should be broken. Then it is converted to RCHO, or it is written as RC double bond OH. So it is produced aldehyde. Okay. So the primary nitroalkanes are involved in the hydrolysis. Then they can produce the aldehyde. Then the next reaction is about, here we can take the secondary alkanes. Look at this. This is secondary alkane. Okay, in this secondary alkane also, one alpha hydrogen is present. It donates the electrons in between the carbon and nitrogen. So this nitrogen oxygen double bonded electrons are shifted to the oxygen atom. Then oxygen get the negative charge and this hydrogen is eliminated as proton. This proton is reacted with the O minus. Then this type of structure is produced. O minus is converted to OH. When it is involved in the acidic hydrolysis, then this bond should be broken. Then it is converted to ketone. Then it is converted to ketone. Okay. So this reaction is called as a Neff's reaction.
Which reaction, ma'am?
Neff, N-E-F. Already here is there, N-E-F. Actually, its name is hydrolysis of nitroalkane. But in your semester book, they mentioned as Neff reaction. Here is there.
Page number, ma'am?
51.
Right.
Who is this? Who is this? What is your name?
Tajammul, ma'am. Tajammul.
Tajammul. You are the degree student?
Yes, ma'am.
Huh? Okay. Then, so here, in the previous, we are discussing those are called as aliphatic nitro compounds because the formula of nitro compounds is nothing but RNO2. RNO2. So in this, we can take the alkyl group, that is methyl, ethyl, propyl. So those type of groups. So that's why those are called as that one. Then aliphatic. nitro compounds. So this class is regarding for the aromatic nitro compounds. So in this alkyl group, we can take the benzene structure, or this formula is C6H5. It is called as phenyl group. The phenyl group is substituted to the nitro group. Then those are called as aromatic nitro compounds. Look at this. These are some of the examples of nitro compound. The first one is nitrobenzene. Second one is 1-methyl 2-nitrobenzene. Because in the benzene ring, these are the positions of 1 and 2. So the benzene ring, the methyl group is attacked at the first position and the nitro group is attacked at the second position. So how we can prepare the aromatic nitro compounds? Okay. So by the reaction with the nitration of aromatic hydrocarbon. So here we can take the ARH, it is nothing but benzene. Benzene is reacted with the HNO3. So HNO3 is written as O2NOH. Then this NO2 group is attacked instead of the hydrogen. Look at this, the benzene is converted to nitrobenzene in the presence of the concentrated sulfuric acid, concentrated nitric acid under 50 to 60 degree temperature. Okay. Then the second preparation method is replacement of diazonium group. So N2H plus, it is called as diazonium. So that diazonium group replacement also, at that we can add the nitro group, then the diazo group is eliminated and the nitro group is substituted. Okay, so this is the second preparation method. Then in the third preparation method also, we can prepare the benzene diazonium fluorate. So this is reacted with potassium nitrate under copper, it is converted to benzene. Then the another reaction is the oxidation. So here we can take the ARH2 is nothing but the structure of aniline is like this. The benzene ring, it is bonded with the NH2. It is called as aniline. Okay, so this aniline is undergoes oxidation in the presence of the trifluoroesteric acid. Then it is converted to nitroalkane. The next is about we can take the amine. Amine also converted to nitrobenzene. So this is written in the formula, it is written in the structure. Okay. Then what are the physical properties of the nitrobenzene? Okay, here the nitrobenzene, it is having high boiling liquid and it is insoluble in water. Okay, the nitrobenzene is insoluble in water and it is having the high boiling point values. Then we are discussing about the chemical reaction. So in this chemical reaction, the first one is the oxidizing property. So here the nitrobenzene, it is involved in the oxidation and it produces the aldehyde product. The nitrobenzene, it is involved in the electrophilic substitution reaction in the presence of the sulfuric acid and nitric acid. They can produce the NO2 group and that NO2 group is attacked at the ortho position, meta position. So nitrobenzene is involved in the electrophilic substitution reaction and it produces meta-dinitrobenzene. Okay. So these are involved in the reduction reactions also. Aromatic nitro compounds are reduced by the variety of reducing agents. The products of reduction depends upon the nature of the reducing agent. The nitrobenzene, for instance, is reduced under different reduction conditions to give the following result. Here, in the presence of the acid media, they give the aniline. Look at this reaction. So here, nitrobenzene, it is involved in the reduction in the presence of the tin iron and HCl. It is converted to aniline. So then this nitrobenzene is reacted with the zinc ammonium chloride. It is converted to phenyl hydroxylamine. Okay, hydroxylamine formula is H2NOH. So here we can take the nitrobenzene. It is reacted with zinc dust in the presence of the OH minus. Then it produces the hydrazobenzene. Then the nitrobenzene is involved in the reduction in the presence of the lithium aluminum hydride. It produces 1,2-diphenyl diazine. Then the next one is the nitrobenzene is involved in the reduction in the presence of the sodium borohydride. It can produce the azoxybenzene. Okay. And these nitrobenzenes are having the sum of the uses. The principal uses of the nitroalkanes have been as solvent in plastic industry. Okay. So here these nitroalkanes are used as the solvents in plastic industry. And they are useful as intermediates in the synthetic pesticides. Pesticides preparations, they are used as the intermediate. Then emulsifying agent, they are used as the emulsifying agent, and they can explosives and pharmaceuticals. So CCl3NO2 chloropicrine is a powerful lacrimator and has been used in the tear bombs. Okay. Then here we can take the trinitrotoluene. TNT is nothing but trinitrotoluene and picric acid. These two are acting as the powerful explosives. Okay, TNT, already you know about the TNT. So TNT is nothing but trinitrotoluene. So it is acting as the powerful explosion. Then next is about the alkyl nitrides. Okay, these are the some of the reactions of the alkyl nitrides and chemical properties. Okay, up to this chapter is over. Okay, thank you one and all.
Thank you, ma'am.
You may
Thank you,
have
ma'am.
notes already.
Thank you, ma'am.
One WhatsApp group is there now. You kept a message on that.